So this exercise is related to electromagnetic induction, and the topic you will find AC generator, DC motor, force on a wire placed in a magnetic field or a current carrying conductor. So the first part in question 2, figure 11.1 shows a flexible wire. So this is a flexible wire hanging between the two magnetic poles. Left side you have north and the right hand side you have south. The flexible wire is connected to a 12-volt DC. So when we have a DC supply, the direction of the force will be a specific direction, one direction it will act. But if it was an AC supply, then the direction of the force will continuously change and it can cause the wire to vibrate. So first part, explain why the wire moves when the supply is switched on. So, and it's of 2 marks. So what is the reason why the wire moves when the supply is switched on? First thing, like when a wire is carrying a current, it produces a magnetic field. And the magnetic field of a wire, like as it is carrying a current, the conventional current is there from positive to negative. So there are two magnetic fields. One is a magnetic field of a wire, and another one is a magnetic field of a magnet. So as a result, there are two magnetic fields. They will interact with each other. That's why the wire experiences a force. So when the wire is placed perpendicular to a magnetic field, because when it is parallel, it does not cut the magnetic field. So when wire is placed perpendicular to the magnetic field, yes, we can say, you can say it cuts the magnetic field. So when wire is placed perpendicular to a magnetic field and it carry the current, or the wire carrying current is placed perpendicular to a magnetic field, produce its own magnetic field, which interact with magnetic field, or which cuts the magnetic field. You can use the term interact, or you can use the term cuts the magnetic field of a magnet, and as a result it will experience force. So the mark distribution, when you mention the magnetic field of a permanent magnet and a current interact with each other or cuts each other, as a result they exert force on each other. Is it clear, the first part, that why the wire experiences the force when it is placed in a magnetic field?
Yes, sir.
The next part, state the direction of a deflection. It's of 2 marks. So how you work out a direction of a deflection? Which rule will use, left or right?
Left.
Left. Because whenever you need a force on a wire, you will use Fleming's left-hand rule. And according to Fleming's left-hand rule, your first finger or your index finger should point in the direction of a magnetic field. And in this case, that is towards the south. So in this example, the south is toward the right-hand side. So your left-hand side, your left-hand index finger should point towards the right-hand side or towards south. Your second finger represents the direction of the current, the conventional current. In this case, the conventional current is down, so your second finger should point downward. Your thumb automatically will represent the direction of the force, where your thumb is pointing. When you apply the rule, index finger is pointing towards south, the second is representing a direction of a current, where your thumb is pointing, towards you or like out of the screen or into the screen. Current is downward. Current is not current is downward, because the conventional current, as you can see, the direction, this is top of the page, this is bottom, right, left. So current should point. So as a result, when you apply the rule, where the force is pointing outward. So this will experience an outward force. So force will be out of the paper. So when you apply the Fleming's left-hand rule, index finger point towards south, which is towards the right. Second is pointing in the direction of a current. And thumb is pointing out of the screen, or we can also say out of the plane of the paper. And why it's of 2 marks, how you score the 2 marks? 1 mark is for, actually, 1 mark is for using the rule here. And the second mark is for the answer, like writing. So when you mention out of the paper, you will score 2 marks because you cannot get the out of paper unless you use a Fleming's left-hand rule. So when we mention out of the paper, you will score 2 marks. And how we got this? By using Fleming's left-hand rule. In the diagram, what is happening in the diagram? There is a current passes in the wire. Whenever there is a current is passing in the wire produces a magnetic field. And that magnetic field interact with a permanent magnet. So there are two magnetic fields. There are two magnetic fields. One is a magnetic field of a wire, another one is a magnetic field of a magnet. Whenever two magnetic fields are interacting with each other, there is always a force on the wire, or force on the magnet and the force on the wire. So as a result, wire is having a magnetic field and magnet is also having a magnetic field. The two magnetic field interact with each other and exert a force. So whenever current carrying conductors are placed in a magnetic field, they always experience a force if they cut the magnetic field. Is it clear?
Yes, sir.
Then state the direction in which that we just mentioned. And when the wire first moved, the energy is changed from one form to another. State these two forms of energy. First, in the wire, which form of energy is there in the wire? The charges are moving. So what we call that energy?
Electrical energy.
Electrical energy. And then the wires start to move. So what we say when a motion is there or a movement is there?
Kinetic energy.
Kinetic. So we can say electrical energy is converted into kinetic energy. And same thing, if we have, like example, a rectangular wire in a magnetic field, like this is a one strand of a wire in a magnetic field. But if we have a rectangular wire in a magnetic field, then it will become a DC motor. So a rectangular wire placed in a magnetic field, and we use the split ring. The split rings are used with a carbon brush, and we are passing a current. So when rectangular wire, it become a DC motor. When a single strand or a piece of wire is there, then it's not a DC motor. It just experience the force either in and out. Or if we change this DC supply to AC supply, then what will happen? The direction of the force will change and the wire will vibrate to and fro. Like in this case, it will vibrate in and out of the screen. So as you can see now, the same concept, but now it has changed to rectangular. So if it has changed to rectangular coil, what it become? It become a DC motor now, which convert electrical to kinetic as well, and it rotate. Figure 11.2 shows a flexible wire made into a rigid rectangular coil. So that flexible wire now become a rectangular coil and mounted on an axle. Add to a diagram the arrangement that will allow the current to be fed into the coil and allowing the coil to turn. If it No, because we are passing a current and the wire rotate, it's a DC motor. If we rotate the wire and it produce a current, then it will be AC generator. That's a difference. In DC motor, it take electricity and move, convert to kinetic. But in AC generator, we rotate the wire and produce electricity. So as they mentioned in the question, that we add to a diagram an arrangement that allow the current to be fed into a coil. Like how we can fed the current, how we can add a current or input a current to this. So means we have to pass a current so that it will rotate. It means we want to convert into DC motor. If we want to convert into AC generator, what will happen? We should rotate the coil and it will turn into an AC generator. So what we have to connect here, we have to connect because split rings should be there. As it's a DC motor, if it was a AC generator, then we should have a slip ring, then carbon brushes, then there will be a supply switch. So it turned out to be a DC motor. And add to a diagram arrangement that will allow the current to be fed and allowing to turn current, and label the parts you have added. So we have to label the parts. So what is this? This one is split ring. And these are the carbon brushes. I'm writing in short CB. This one is a supply, and here is a switch. Is it clear, this one?
Yes.
Then in the second part, briefly explain how your arrangement work, like how this will work, how this DC motor will work. So normally, like what happens when it rotates, after every half turn, the current which is passing from one ring to another, it changes the direction and cause a continuous rotation. Yes, we can just add batteries as well. Not only battery, there must, because it's a DC motor. So they're important. The marking points are split ring and carbon brush. Battery, your supply can be added, but that's not having mark. The main mark distribution for labeling a split ring and the carbon brushes. So briefly explain how the arrangement works. The current passing through the coil or a rectangular coil. Changes direction after every half rotation. So the coil will rotate in one direction. And when the coil is vertical, there will be no connection, so no current, but it will continue to move because of its inertia. So this is actually a working of a DC motor. When after every half rotation or 180-degree rotation, the current will become opposite. Like in that, what sense opposite? Like this is A, B, C, and D. So if the current was moving in this way, first, when it flip, when it changes the direction, so if we say like this was a DC motor, which is having split rings and the carbon brush, so A, B, C, and D. If the conventional current was from A to B, then B to C and C to D, then after 180-degree rotation, as AB position will change, AB will be on the left-hand side and CD will be on the right-hand side. So this will be C, D, B, and A. The direction of the current will be reversed. Now you can see the direction of a current is from D, C, B, A. Before it was A, B, C, D. How this makes a wire to rotate in one direction, as you can see, for example, if AB was experiencing a force into, AB was experiencing force into and CD will experience force out. So AB is into, CD is out. When the direction of AB, like AB after 180 rotation, AB is on the left hand side and CD is on the right hand side. Now CD will experience an inward force and AB will experience an outward force. So again, it will flip 180. So direction, when AB is on the right hand side, the direction of the force was in. But when AB is on the left hand side, the direction is out. So as a result, every time, every half rotation, the direction of the current or the force changes, which cause it to move in one direction, either clockwise or anti-clockwise.